So number 94, as I was saying at the tail end of the last video, is really similar to number 92 in that this guy right here has no y's in it. We've got the y right here in our argument, and we're gonna unlock that, and we unlock that by rewriting this entire equation in exponential form, and then we just subtract 4. But at the same time, I am going to go ahead and take it one step further to the fully simplified version. I'll keep that y plus 4 over here for now, and then reminding you that e to the ln of c, that's just c, because both e and the log have the same base, so that's just c, and so we're going to write that as c times e to the 5x equals y plus 4, and then hopefully recognizing that again we're solving for y, so we're just going to subtract 4 from both sides, and that's e to the 5x, c times e to the 5x, all minus 4, and that's equal to y. That's it. I'm going to go ahead and pause this and flip over to page number 96. And number 96, this is the granddaddy of them all. We're going to go ahead and do our best to make sure that we just have one ln on one side and one ln on the other side. Okay, we're going to use the properties of logarithms. We're going to move the coefficient to the exponent position. That means that we can rewrite 2 ln y as ln of y squared. We can write negative 1/2 times ln of x as ln of x to the negative 1/2. Plus, we're going to move, so I move that, I move this one, and we write this 1/3 times this stuff as ln of the stuff raised to the 1/3, and then plus ln of c. And these are plus signs. Oops, I didn't mean to do that. These guys here are both plus signs, so we get to we have the sum of the logs, so we're going to take the log of the product. Okay, so we have y equals ln of y squared equals the ln of this whole product, x to the negative 1/2 times x squared plus 1 to the 1/3 times c. So this whole thing is what we're taking the ln of, and therefore, since we have the ln on both sides, same base, we have y squared equals, let's put the c out in front, c times x to the negative 1/2 times x squared plus 1 to the 1/3, and this is getting very ugly, but nevertheless we need to solve for y, and solving for y, we get y equals let's see, y equals the square root of, would we have the absolute value of the square root of that? Let's leave it as that, c times x to the negative 1/2 times x squared plus 1 to the 1/3, and we can leave it just like that. Normally square root of y squared, you get y equals plus or minus, and I'm doubting here, could y ever be negative? No, that's why I was doubting, because I look back to the original equation, that negative symbol there means that this whole thing would be negative, and you're not allowed to take the ln of a negative number. So we would have to throw that out, and we would just get the positive square root of c times x to the negative 1/2 times x squared plus 1 to the 1/3.